Welcome to this YSL Excel VBA tutorial. This video explains how to use the join function and concatenate strings in VBA. We'll begin the video with a quick recap of concatenation, including the two different operators you can use to concatenate strings and which one's the best one to use and why. We'll move on and look at how you can accumulate strings in a string variable, so to build it up piece by piece. We'll talk about briefly how you can concatenate special characters, such as tab characters and new lines, before we move on to the second half of the video talking about the join function and how to concatenate the contents of an array into a single continuous string. When we talk about that, we'll need to talk about how you transpose arrays, because we're going to be working with ranges of cells, and that will all become clear when we get onto that section of the video. And then to create a couple of fairly practical examples, the last part of the video is going to show you how you can write those concatenated values out to text files. So quite a few interesting ideas here. Let's get started. Okay, so the starting point for this video is our fairly standard workbook full of data about movies. There'll be a link in the video description that you can use to download this dataset, or if you've already got a copy from one of the two previous videos, you can just carry on using that one instead. It's exactly the same data. Regardless of how you get hold of a copy, let's head straight to the VB editor. I'm going to press Alt and F11, and then from there I'm going to insert a new module into the project, and we'll create a first subroutine called something simple like basic concatenation. Then we'll just have a very quick reminder of the simple technique of concatenating strings. First things first, we'll make sure that we've got a variable that can hold the string we're going to concatenate, so I'm going to say dim s as string, and then I'm going to make sure that I've selected a cell containing a film name, so just to make it easy to change a little bit later on, let's go with range a2.select, so that's got the film Jurassic Park in it. What I'm then going to do is just try to concatenate the film name along with the name of the director. So in this case it's going to be the active cell's value along with the value of the cell that's 2 columns to the right of the active cell. So nothing particularly complicated. We've done this sort of thing many times in the past, but just to, as I say, to very quickly go over the basics, I'm going to say s equals active cell dot value, and I'll get that spelled properly eventually. And then to concatenate another string to the first in VBA, you use the ampersand character, so shift and the number 7 on my particular keyboard, my English keyboard. I want to concatenate a literal string in between the film name and the director name. So if I want to concatenate a literal string, I can open a set of double quotes and then write something in. Let's just start by adding a simple comma, and then close the double quotes, and then another ampersand to join on the next bit of text, which in this case, as I say, will be active cell.offset 0,2.value. And I'll go for value rather than validation, as I keep on doing. Finally, all I'm going to do at this point is debug.print the value of my s variable, and if I were to simply run that subroutine by hitting F5, unsurprisingly I get those two bits of text joined together, those three bits of text including the comma, joined together into a single continuous string. Now you may remember from a couple of videos ago that there's actually another symbol you can use to concatenate strings. Rather than using an ampersand, I could have used the arithmetic plus operator. This is common with other languages such as Visual C# and SQL. They use a plus symbol to join bits of text together. And if I were just to select a different cell as well, just to demonstrate that this works, and then run the subroutine again, I'll get another film name and another director name joined together with a comma separating them. Now, although this works beautifully when you've got two bits of text being joined together, the plus symbol does tend to break down and fall over a little bit if you try to concatenate a bit of text with, say, a number or a date. So, for example, if I tried to concatenate the runtime in minutes of the films, that's 4 columns to the right. So, I beg your pardon, 3 columns to the right, just after the director's name. If I were to try to change this so that we're looking at the value of the cell 3 columns to the right, and then run that subroutine again, we'll see this time it falls over. So there's a couple of ways you could solve this. The slightly long-winded way would be, if I just end the procedure at this point, would be to explicitly convert the value of that cell into a string. So again, you may remember from an earlier video, you can use the cstr function, cstr, to convert that to a string. And as I know that that one's going to contain the number, I can run that one again, and this one now works. Just to be absolutely certain, I'd want to make sure that I do that for every single value that I enter into the string. So I need to convert each individual value, which is makes it sort of a little bit tedious to perform. So much simpler in VBA terms. You've got this luxury in VBA where you have a separate dedicated symbol for concatenating strings that effectively performs an implicit type conversion. So whatever values you're trying to pass into the string or build into your string will always be converted into into a string automatically, regardless of whether they were numbers or whether they were dates. You'll just always get everything converted into a string. Another reasonably useful thing that you can do with strings is accumulate them. So let's say that I wanted to build a single string that contained all of the values from a single row of data, joined together maybe with a comma separating each value, or maybe a tab character delimiting each value. I could write a separate concatenation for each individual column in the row, but that gets really tedious if I have lots and lots of columns. So much more sensible to loop over all the cells in a single row and then concatenate each value one by one. Now, in order to make that work, we're going to need to use a variable that we can accumulate a string in. So we're going to sort of overwrite the string with itself plus another bit of text. Let's have a quick extra subroutine to demonstrate this. Let's call this one accumulating strings. So we're going to use again basic concatenation. So I'm going to have a variable called s as string. I'm going to loop over the range of cells in a row using a variable called r. So we'll use a range variable for that, and we'll use a for each loop to loop over the row. I'm also going to use another variable that's going to count how many columns are in each row. So I'm going to say I said dom, it was meant to be dim, cols as integer, so it's just going to count how many columns there are. A simple easy way to count how many columns there are is to refer to the entire region of data in which the top left hand cell sits. So I can say cols equals range A1 dot current region, and then from there I can refer to the number of columns by saying columns.count. So that will store the number of columns, and that makes it nice and easy to loop over all of the columns in a single row. So what I can do here is, regardless of which cell I've selected, let's assume I'm going to stick with cell A4 for the time being, I can write a loop which says for each R in. Then I can say active cell, and I'm going to use a resize method. So there's a property, beg your pardon, called resize, which allows you to specify a new row size and a new column size for a range. So the row size is going to be 1. I want to stick with just this one single row of data, but the column size is going to be equal to the value stored in my cols variable. So I can do this like so. So I can say resize 1, cols, and then a couple of lines further down I can say next r to move on to the next cell, and then inside the loop what I can do is build up my string. So I haven't assigned a value to my string. It begins as an empty string, so it's got a 0 length string stored inside it, sometimes referred to as a null string. And what I can then do is say s equals, and I can make it equal to itself and the value of the next cell. So I'm going to say r.value, and then I can also say I want to put in a comma to separate each value. I can say ampersand comma. If I then finally at the end say debug.print s, then we'll see what the result is. So I'm going to clear the contents of the immediate window and then run that subroutine just to get a single continuous row of data. Now, one minor issue with this little technique is that I always end up concatenating an extra comma that's not necessary. If I scrolled all the way to the end in the immediate window, you'll see right at the end I've got an extra comma that I definitely don't need. So there's a couple of ways I could handle that, but a quick, simple, convenient way is to wait until I've finished looping and then strip off the very last character of the string. So I can make s equal to you may remember from the previous video we looked at the left, right and mid functions. I'm going to use the left function here to return a number of characters from the left hand side of this string. The number of characters that I want, so the length of the characters that I want, is equal to the entire length of the entire string minus 1. So there's another function I can use called len, L-E-N, which returns the number of characters in a string, and from that I can simply subtract 1 to return all the characters except for the very last character in the string. So if I were to run this one again, having just added that single line, just compare the two results, I get the comma missing from the end from this new version. Now, it's probably worth having a quick reminder that it's not just literal strings that you can insert into your concatenations. You don't have to stick with a comma or, for instance, a space. It doesn't have to be something that you literally type in inside a set of double quotes. There are several different constants in VBA that allow you to insert special characters such as tabs and new line characters. So if I replace the double quotes and whatever character I typed inside with something like a VB tab, that would insert a tab space between each value. So if I were to run that one at this point, we'll end up with a new line. So I'll have 3 lines in total, but this one has tab characters in between each value. There's another one called VB new line, which is the most commonly used, or the one that you should be using most commonly to add in new line characters in VBA strings. There are several other versions of the VB new line constant, which we talked about in a lot of detail in one of the earlier videos. I'm not going to go back into that right now, but if I were to again just click into the immediate window and then again click to the subroutine and run it again, we'll end up with each value this time separated with a new line character instead. Now, although this technique works and it's reasonably easy to understand, there are a couple of minor inconveniences with it. First of all, we have to loop over each cell individually to concatenate them into the string. Secondly, we have to strip off the trailing character right at the very end of the concatenation as well. So if we wanted to solve both of those two problems, there is a technique we can use to simply join a number of cell values together into a single string with a delimiter character of our choice. There's a function that's designed to do exactly that, and it's called join. Just to give you the absolute basics of how the join function works, we need to build up towards this example. There are a few little complications we need to investigate along the way, but the absolute basics of the join function, let me create a quick new subroutine called join function. And sorry, I'm going to join function rather than join functions. And once again, we'll have our basic s variable, dim s as string. And then what I'm going to do is I'm going to say s equals, and then I'm going to use the join function. So if I say join and then open some parentheses, you'll see the first parameter here says source array. So the first stumbling block with the join function is that it requires an array of values to join together. We can quickly generate a simple array using the array function. So if I say array, then open some more parentheses. This is going to seem completely pointless, by the way, just to demonstrate the basic principles. You'd never ordinarily, I think, do this. There are far simpler ways to achieve the end result of this specific example. But my array is going to be built of a number of simple strings. So let's say, I don't know, it can be A, comma, B. So these are all individual separate strings. And then what I would like to do, if I close the parentheses and type in a comma, I can specify what delimiter character gets used. So I could say here, let's say a VB tab character to separate them all out, and then right at the end I could simply say debug.print s. So if I were to clear the contents of the immediate window now by selecting it and pressing Ctrl A and then deleting everything, and then just run this simple subroutine, the results aren't impressive by any means, but you can hopefully see that the values we passed into the join function, or the values stored in the array that we've passed into the join function, have all been separated with a tab character. Now, what would be absolutely lovely at this stage would be if I could simply replace my array function here with a reference to the range of cells that I wanted to pass into and join together in the join function. But sadly we can't. It's a little tiny bit more complicated than that. So let's just take you through step by step as to how we can achieve that result. I'm going to create another new subroutine just down below these last few. I'm going to call this one joining range values. I'll spell joining properly first as well. So joining range values. I'm then going to steal a few lines of code from one of our previous routines. Let's copy these three variables and the line which sets the value of the cols variable, so it calculates the number of columns in a row. If I copy those and then just paste those into my new subroutine, just for the moment we can delete our range variable. We shan't need that. We're not going to loop over the range of cells in a single row. What we'd like to do then is try to store a range of cells in my s variable. So if I say s equals, then I'm going to say join, and then rather than referring to the array formulae, what I'm going to do here is say active cell dot resize, beg your pardon, let's try that again, active cell dot resize, just as we did earlier on, a row size of 1 and a column size of cols. If I then try to delimit that, let's say with a VB tab character again, and then if I were to attempt to run this subroutine at this point, you'll see that when I hit this line, I'm using F8 to step through. If I hit this line here, I'm going to end up with a runtime error, a type mismatch. It's not immediately obvious what the problem is, but the problem is that the type of array that we're passing into the join function now is of the wrong type. The join function requires an array with one single dimension, and when you refer to a range of cells like this, either just as a reference to the cells or even just to the value of those cells, then what happens in that case is it creates a two-dimensional array, and the join function simply can't accept a two-dimensional array. Let's see if I can demonstrate that in a little tiny bit more detail, and as well as that, show you the solution to that particular problem. It's going to be slightly easier to explain why this solution works if we have a separate variable to hold the array of values we want to pass into the join function. So what I'm going to do is declare a new variable. It's actually going to be an array, which I'm going to call ARR, then open and close some parentheses, and the type of this array must be a variant. So you could just say as variant if you really wanted to, but there's absolutely no need, and you can just say dim ARR, and that will automatically declare an empty variant array. we might as well comment out this line for the time being, as we know that one's not going to work. And then after we've calculated the number of columns, what I would like to do next is I'd like to try to store the range of cells in my array. So the array cells that I just referred to here. So I'm going to say ARR equals, and then I'm going to say active cell.resize 1, cols.value. So I can just happily copy and paste that from the line I've just commented out. Now, just to demonstrate what this does, I've made sure I've got the locals window displayed here at the bottom of the screen. And if you haven't got that, you can head to the view menu and choose locals window, of course. If I use the F8 key to begin stepping through, when I reach this line and assign a set of cells to an array, or a set of values of cells to an array, you'll see that whereas as it's currently empty, as soon as I press F8, that's populated with a two-dimensional array. You can see, hopefully you can just about make this out in the locals window, that I've got the first dimension containing one element, 1 to 1, and the second dimension containing 11 elements, 1 to 11. So that's the reason I can't simply pass my range into the join function, because the join requires a single-dimensional array, not a two-dimensional array. Let's just stop running that one and look at some of the solutions we could apply to fix this problem. Again, this is probably slightly easier to demonstrate if I first of all comment out this line and then show you a slightly different form of what we're about to do. This is going to be easy to demonstrate if I start with referring to a column of cells rather than a row. So if I say ARR equals, what I would like to do is take a column of cells and then transpose them. So you may be familiar with a transpose function in Excel, where you can take a set of cells organised in a column and then apply transpose, which would convert those into a row, and vice versa. You could select a row and transpose that into a column. Now if I were to do this here, if I just, let's say, ARR equals range, or in fact, beg your pardon, let's start with application.transpose, which sadly doesn't appear in the IntelliSense, but never mind, we can definitely use this, application.transpose, and then we can refer to, let's just say, range A1 colon A10, for example. What we can then do, if I were to F8 through this subroutine, you'll see that when you refer to, as we saw earlier on, when you refer to a range of cells, it returns a two-dimensional array. When you transpose a column of cells into a row of cells, as this line is about to do, that generates a single-dimensional array. So you can see here, hopefully in the locals window, that I get a variant 1 to 10. So there's only one dimension, and we could happily assign that to the join function. So if we just were to quickly try to do that, let's say S equals, and then I can say join ARR, and then separate this with a VB tab character, and then let's at the bottom just say debug.print S. So running this entire thing, sorry, beg pardon, that was meant to be join rather than join, I'm not quite sure what I was trying to spell there, and then if I were to run that entire subroutine, I'll end up with, I should have cleared the contents of the immediate window first, but you can see each value listed out separated with a tab character. So that's the basic principle. If you convert a column of cells or transpose a column of cells into a row, it generates a one-dimensional array. The problem that we've got here is that we're trying to transpose, or we're trying to convert a row of cells into a single-dimensional array, and that's a little bit more fiddly to do. So here's a solution to that problem. Let's just remove this line here that we added in, and then let's uncomment the original assignment of this array. So if I were to say here, for example, array equals application.transpose, I'll spell transpose properly, it's slightly awkward with the without the IntelliSense to help. If I try to do that with my single-dimensional array, what's going to happen is, if I use F8 to step through, you can see that it's an empty array currently. As soon as I hit F8 on that instruction, it generates another two-dimensional array, but this time rather than just having one element in the first dimension, it's got 11 elements in the first dimension and one element in the second. The problem is, of course, that we've still got the same exact problem. If I were to attempt to assign that to the join function, or pass that into the join function, then it falls over, because the join function can't accept a two-dimensional array. So the slightly odd, weird solution is to simply transpose the transposed row. So currently that row of data has been transposed into a column, and we've just seen that if we transpose a column into a row, it generates a single-dimensional array. So it's a slightly weird technique to use, but if I just copy application.transpose, open parentheses, to the start here, and then close the extra set of parentheses at the end. And what we'll see this time, if I use F8 to step through, once again, an empty array currently. If I execute this line, I've got a single dimensional array consisting of 11 elements in one single dimension, and that means that I can now assign that to or pass that into the join function, which means that I can now happily print out the entire string with each value from the row separated with tab characters. Phew, it's a little bit of an awkward one, certainly to understand. It's not a particularly well documented feature either, this. As you can see, it's not even in the IntelliSense list. However, this is probably the neatest, simplest, quickest way, probably the most efficient way to transpose or store a row of cells in an array and then pass that into the join function. We could tidy up this entire technique now just to generate a few less lines of code. So if I just delete the commented outline down here, and then let's not perform this in two separate lines. We don't really need the array variable here at all. There's no reason to assign the range of cells into an array and then join them. We could just do everything in a single continuous instruction. So let's take this part of the code where we're transposing the row. I'm going to copy that part and replace the reference to the array in the join function on the next line. So I'm just going to paste over that so that everything's on a single line. That means we can get rid of the line which populates the array, and we can get rid of the array variable as well, just make things a little bit neater. And if I were to just select a different cell in the worksheet, just to demonstrate that this does still work, and clear the contents of the immediate window, run that one more time, and that's a much neater, simpler, shorter, succinct version of that same procedure. Okay, so that's a bit of the background theory behind concatenating and joining strings. What we'd like to do now for the last part of the video is create a couple of practical examples using these techniques. So the first one, what I would like to be able to do is generate a text file that contains tab delimited values for every film that's listed as an action film. So that means I'm going to need to loop over the entire table of data, which is about 1200 rows, check whether each film is an action film, and if it is, I want to take that entire row of data, build it or join it into a tab delimited string, and then write that out into a text file that's going to end up sitting on my desktop. So to get started with that, let's head back to the VB editor, and I'm going to copy and paste this entire subroutine, the one that we've just finished writing, and then if I paste it in and give it a new name, let's call this one, I don't know, something like list action films. We'll add a couple of extra lines of code as well. If we're working with text files, perhaps the most convenient way to do that is using something called the Microsoft Scripting Runtime Object Library. We have a separate video as part of this main series all about working with text files, and another one as well, of course, actually about working with arrays, if you haven't seen those ones already. So I didn't spend a huge amount of time talking about arrays there in detail, but we have other videos in the series which do. So the easiest way to work with files and folders is referencing the scripting runtime library first. So if you head to the tools menu and choose references, and then in the list, what you're looking for in this list is something called Microsoft Scripting Runtime. So if I scroll down far enough, I will find eventually Microsoft Scripting Runtime, and there it is. If I check the box and then click OK, that allows me to write a couple of extra useful lines of code up at the top of this subroutine. So I'm going to start by saying dim fso as new scripting.filesystemObject. So think of that as a sort of space in memory, like a memory-based version of Windows Explorer window that lets you manipulate files and folders. I'm then going to declare another variable that's going to hold a reference to a text file, which is going to be called ts as a scripting.text stream. And I'm also going to declare an extra variable which is going to hold a range. So I'm going to loop over an entire range of cells, that entire column of film names in column A. So dim r as range. Okay, so I've calculated the number of columns. What I'd like to do next, before I start looping over the cells, is generate a new text file that sits on my desktop. So I can do that by saying set ts equals, and then I'm going to say fso dot. I'm going to use a method called open text file. There's a couple of ways to do this. I could create a method that says or use a method called create text file that would assume the text file doesn't exist and create it from scratch. Alternatively, there's a method called open text file which will try to open an existing file, and if it's not there, it can also create it to make it available. So I'm going to use the open text file method, and then the first thing I have to do here is specify the file name. That's a full file name and folder path. So I want to stick this text file on my desktop. So to generate that, I'm going to concatenate the file and folder path. So here we are using some practical techniques, or using some techniques practically, I should say. There's a function in VBA called environ, and you can ask the environ function for a variety of bits of information. The one I'm going to ask for is the user profile, and then to the end of that I would like to concatenate a literal string, in fact, \desktop \action.txt. So that will be the full file name and folder path of the file I want to generate. If I type in a comma, there's several different modes I can open the text file in. I want to make sure that I can add new data to the end of the existing text file, so I'm going to say for appending. And then finally, I want to make sure that the file will be created if it doesn't exist. So that extra parameter there, create, I'm going to set that to true, close the round brackets or parentheses, and then hit enter to go to the next line. Let me just bring this onto two separate lines so you can see the entire string in one screen width. So that will generate our new text file. Now we can start looping over the films and writing out the appropriate ones to it. We'll use a simple for each loop to loop over the range of cells we want to process. So let's say for each R in, then I'm going to refer to range A2, as that's the very first cell which contains a film name, so that's Jurassic Park of course, and I want to carry on looping down to the very last cell at the bottom of column A that contains a value. So if I say range A1.end XL down, that's a quick simple way to jump down to the end of the list, so XL down, close two sets of parentheses, and that loop will process the entire column of populated cells. I want to make sure that I move on to the next cell in the list, so give myself a couple of blank lines and say next R. I can get rid of the debug.print statement here. I don't need to print the value of S. I do need to assign a value to the S variable, and I'm going to do that in exactly the same way as I did earlier on by transposing twice the row of data that I'm currently looking at. One thing I do need to change is a reference to the active cell. So because I'm not physically selecting the cells, this for each loop will process the range of cells in memory effectively. It's not going to physically select them. So instead of referring to the active cell, I'm going to refer to my variable R. I just indent that line of code so it's a little bit easier to see where the loop begins and ends. Of course, I only want to do that if the film that I'm looking at currently is an action film. So to test that, I want to check if the value of the cell that's 1, 2, 3, 4, 5 columns to the right of R contains the word action. Now I want to make sure that I'm not using case-sensitive searches here as well. So the word action should be spelt with a capital letter A in every single row for an action film, but I can't guarantee that. So I'm going to use another function we looked at. Actually, we saw this in one of the previous videos, the lcase function, to convert strings to lowercase. So I'm going to say if lcase, and then open some parentheses, and then say r.offset 0,5.value, and then ask if that is equal to the word action, and I'm going to write that out all out in lowercase as well, of course. Then I want to build up my string, as I've just done, and store that in my string variable, and then I want to write that string out as a single continuous line into my text file. So to make that work, I can say ts.writeLine, and then I can pass in the value stored in my s variable. If I make sure I close my if statement by saying end if, and then right at the very end, once I've finished looping over all of that, I'd like to close the text file so that it won't be opened actually physically in Notepad or anything. This will close the connection to the text file. So, having done all that, let's just check quickly, briefly on my desktop. If I press Windows D, I don't currently have a text file sitting on my desktop, but if I redisplay the VB editor and then run that subroutine, I will end up, hopefully, with a new text file sitting there called action, and if I simply double-click to open it in Notepad, this is a list of all of the action films. Okay, so that technique works reasonably well, but what if I wanted to do something a bit more sophisticated? Let me close down the action text file and then have another look back at the movies workbook. What if this time I wanted to process the entire loop, and rather than just looking for a single specific genre, I wanted to generate a new text file for every genre that I encounter. So I'll have a separate text file for adventure films, one for action films, and so on. That doesn't require many changes to the code we've already written, as it turns out, so let's head back to the VB editor and let's just copy the entire subroutine we've just finished writing, and we'll paste that in just down below again. I want to call this one something like, I don't know, create genre files, something along those lines. I'll spell create properly as well. Create genre files. Now I'd like to make sure that these files get put into a separate folder. I don't want to clutter up my desktop too much, so I'm going to have a couple of extra variables in this procedure. So after we've said dim cols as integer, let's say dim folpath or folder path as string. And then let's also have a dim genre as string, just to make life slightly easier when we write our logical tests. What I can then do is start rearranging the code in here. I'm going to add a new line that's going to generate a new folder path to hold all of my genre files. So after I've calculated how many columns I'm working with, I'm going to have a new line which is going to say folpath equals, and then again I'm going to use my environ function. So I'm going to say environ and then refer to my user profile again. And then what I'm also going to do is concatenate to the end of that \desktop \, and then the name of the folder I'd like to generate will be genres. What I can now do is check whether that folder exists, and if it doesn't, then I can create it, and I can do that using my file system object, my FSO variable again. So if I say if not FSO dot folder exists, and then I can pass in the folder path that I've just constructed here using some basic concatenation. So I can say folpath, and if that's the case, then I can create that folder. So I can say FSO dot create folder, and then again I've got to pass in the path to the folder I want to generate. So that's going to be folpath. Okay, so at the end of that line, I'll end up with the folder that I want. The next thing I'd like to do is start looping over the range. So rather than opening up a single text file to write out all the data into, I want to loop over all of the cells in the entire range. So I'm going to move the for each line so that it sits just above the set TS line. What I can then do is store the genre that I'm looking for, just to make life slightly easier in the next stage. I want to store the genre that I'm looking at. So I'm going to say inside the loop, the first thing inside the loop, I'm going to say genre equals, and then it might make sense just to copy the r.offset 0,5.value rather than writing it out again. When I've stored the genre, I'm going to use the value of that variable to generate a new text file. So I've got this line here that says set ts equals fso.open text file, but it's always going to generate or try to open up a text file called action stored directly on my desktop, which isn't what I want, of course, at this point. So let's get rid of the environ user profile part. I want to replace that with a reference to my folpath variable. So let's refer to folpath. And then I want to concatenate not the \desktop action.txt. So let's just take away this little section here, the \desktop action. I want to concatenate just a single / character. And then I want to concatenate the value of the genre variable, so ampersand genre, and then finally to the end of that I want to concatenate the file name extension, so .txt. So what that will do is generate a new file for every genre that I encounter, one called action, one called adventure, and so on. Now we don't need to write any more code to get this procedure to work. That's all of the additional code that we needed. So let's just tidy things up a little bit. I'm going to indent these next two lines so that they sit inside, or nested inside, indented inside my for each loop. We don't need to test now if we're looking at an action film, so we can remove that if statement and its corresponding end if, of course. So let's get rid of the end if as well. Then I can outdent these two lines. If I give myself a new blank line, let's just outdent these by selecting both and pressing Shift and Tab just to get everything lined up. I also want to make sure that each text file I'm writing to gets closed after I've finished writing a single line. This might not necessarily be the quickest way to achieve this result, but that's the way I'm going to go for. So each time I write a new line to the text file, I'm going to immediately close it down so that we can open up a different one in the next iteration of the loop. That's basically it, unless we want to do any sort of tidying up. But apart from that, that's this new version of the procedure that will do an awful lot more work than the original one. So let's just give this one a quick test. If I view my desktop again just to prove that we don't have that folder sitting there already, and then just bring back the VB editor window, click into the subroutine and then just hit the play button to run the entire thing. It's going to take a little longer to run, of course, so you see the genres folders appeared automatically, but there are 1200 individual rows to process this time, but that's finished now. So if I go back to my genres folder at this point, I should end up with a new text file, each one containing a different set of film genres. You get a bit of an idea about how biased my database is towards action movies, for instance. So I can, and science fiction movies as well, by the way. So if I double click on the science fiction movies, you'll see that it's all the sci-fi films, and then if I go for the action movies, it's all the action movies, etc., etc. So hopefully you can see that some of these basic techniques, although they do seem quite basic to begin with, in fact, of course, simple concatenation is incredibly basic, but it has so many practical applications. The join stuff isn't absolutely necessary, although it can make certain operations quicker. I certainly prefer, I think, to join a row of data rather than trying to loop over the row and concatenate each individual cell value. So, hope you found some of those things useful, and you can adapt those examples to your own needs. Thanks for watching, see you next time. If you like what you've seen here, why not head over to the WiseL website, where you can find loads more free resources, including these videos, some written blogs and tutorials, and even some exercises that you can download to practice your skills. Thanks for watching, see you next time.